Okay, for part 2 of this video, what I'm going to look at are the questions that say your RLC circuit is at a resonant power factor, a power factor of 1, or at a unity power factor. Okay, they're all saying the exact same statement, just worded slightly differently. The big thing to remember is as you're progressing, unity power factor or a power factor of 1 in a series RLC circuit is significantly different than a power factor of 1 or a unity power factor in a parallel RLC circuit. They are very different things, and we'll look at why. So at a power factor of 1, it means the energy that I am putting into the circuit, I am getting directly out. So the energy that is contributing to the output is the watts of this circuit, meaning the only thing opposing the flow of current in that circuit is the resistive part, or my baseboard heaters or my light bulbs are the only thing that I'm getting out of that circuit, their power output. So at this point, it means that my inductive reactance and my capacitive reactance are the exact same magnitude. So if we just think of a common circuit where this resistive load, let's not think of it as a heater, we can. Let's just think of this resistive component as the wire that I use to hook this up. So let's say that it's a number 10, which is somewhere around 0.01 ohms per 100 meters. So that resistive component of that circuit is very, very small. Just to give us a number, let's say that it's 2 ohms. Okay, that's the resistance of that circuit. So when we are at a power factor of 1, when we're at unity, it means the inductive reactance, which is based on the XL of that circuit, is the same as my capacitive reactance. Just to give it a value so we can see this, let's say this is 20 ohms. Okay? So my inductive reactance is 20. My capacitive reactance also must be 20 ohms. And don't get it confused with the capacitance and the inductance have to be the same. It's not. The inductive reactance and the capacitive reactance have to be the same. So we look at this diagram. The XL and the XC are 180 degrees displaced. They cancel each other out. So the only impedance of this circuit is based on the resistance. Okay? At this point in our circuit, if we look at, I equals E over Z, Ohm's law. At this point in our circuit, this is unity in series RLC. Okay? At this point, and you can look at it as I have an inductor and I add a capacitor, or however you'd like to envision this. At this point in our circuit, we have limited our impedance to its smallest value. There's no way to get rid of that resistive component. That's based on the wire that you hooked up. And that conductor is going to have some value of resistance. There's no way to get rid of it. Okay? So I have limited my total opposition to as small as possible. Because right now, if you want to do this, we looked at X net, it would equal 0. If my opposition is as low as possible, that means my current is at a maximum. There's no way for the current to be as high. So the maximum amount of energy or the maximum amount of current that my system can supply is present. This can be a very, very high, very dangerous scenario because you can have massive volt drops across these two components. It doesn't mean that it never happens. I know we never connect an inductor in series with a capacitor. If you're going to increase the starting torque of a motor, there's a start winding, and you can add a capacitor in series with that start winding to increase the starting torque. But we would never power factor correct in series because your current goes through the roof. From this point, there's no way to get current any higher. So the common question, if I change frequency, and you can plug in the numbers, okay? The frequency, 2 pi FL, and XC is 1 over 2 pi FC. One of them is directly proportional. One of them is inversely proportional. So if I increase the frequency, my inductive reactance will increase. If I increase the frequency, my XC would decrease. I'm no longer at unity. I would be at a lagging circuit. Okay? But if we look at this concept right here, there's no way to get current any higher. If I make a change that's going to take me away from unity, current has to decrease. There's no other way that it can go. So if it's at a maximum at this point and I change frequency, current has to decrease. So let's just give it a value just so that you can see that. So let's say we increase frequency, we doubled the frequency. I'm going to double my XL. It was 20, now it goes to 40. Well, if I increase the frequency, if I doubled the frequencies from 60 to 120, my XC would have to half. It would decrease by that inverse. So when it was 20, it's no longer going to be 20. It's now going to be 10. Well, my total opposition, I started, my impedance was 2. My X net is no longer 0. My X net is now actually 30 ohms. So I look at my total impedance diagram. This is where we started, 2 ohms. There was no vertical component because we canceled it out entirely. Now I have a vertical component. In this case, my circuit will become more lagging. It's more inductive. So my impedance has just increased. So this is not the statement anymore. We just increased the impedance. Ohm's law said my current has to decrease. I hope this has helped. There's been lots of good questions. See you in the next one.